Hi students! Today we're going to look at factoring special forms. This is going to be directly related to the special products that we saw about a week ago. I'm going to start by reminding you of the three special products that we saw, and we're going to look at how we can view these differently as factoring methods. So let's recall the very first special product. It said that if we had a sum of two terms times a difference of those same two terms, then we could multiply it by taking the first term squared minus the last term squared. Well, what we can do now is we can flip the two sides and look at this slightly differently. So now we're going to look at f squared minus l squared and recognize that this is equal to f plus l times f minus l. There's a name for this. We call this the difference of two squares because that's exactly what it is. It is one thing squared minus another thing squared. And we can use this as a method of factoring anything that's in the form of a difference of two squares. For example, let's look at x squared minus 9. This is a difference of two squares. The first term is x squared, and the second term is 3 squared. So we can use this formula to see what the factorization is going to be. We're told we need to take the sum of these two quantities, and in this case that's x and 3, so it's going to be x plus 3 times the difference of those quantities, x minus 3, and this is the factorization. If you want to check, you can do that by multiplying it out. And to do that, we can remember that this is a special product. When we've got the sum of two terms times the difference, we can take the first term and square it. X squared is x squared. And then minus the last term squared. 3 squared is 9. So we get x squared minus 9. We are literally just using this special form in the exact opposite way. Instead of going from the two things being multiplied to get the product, now we're taking the polynomial and writing it as a product to factor it. Let's do a couple more. Let's factor 4y squared minus 121. Again, this is a difference of two squares. 4y squared is a perfect square. It's 2y squared. And 121 is a perfect square. It is 11 squared. So because these are both perfect squares and it's a difference, this is the difference of two squares, and we can use this formula to factor it. The formula says we take the sum of those quantities, 2y plus 11, times the difference, 2y minus 11. And that's our final answer. We're going to do one more of these, and then we're going to move on to the other two types of special forms. This time, let's factor x to the 8th power minus 81. All right. X to the 8th is a perfect square. It is x to the 4th squared. And 81 is a perfect square. It's 9 squared. So using the difference of squares, we end up with x to the 4th plus 9 times x to the 4th minus 9. But we're not actually finished yet. I want you to take a look at this second factor, x to the 4th minus 9, because it is a difference of squares itself, so it can be broken down even further. X to the 4th is x squared squared, and 9 is 3 squared. So we're going to leave the first one alone, and I'll talk about that in just a minute. And then the second one is a difference of squares, so it breaks down into x squared plus 3 times x squared minus 3. This first factor could not get broken down any further because it's not a difference of squares, it's actually a sum of squares. And we are not able to break down or to factor a sum of two squares. It's only a difference of squares that has a formula that allows us to factor it. We will look at a sum of two squares in a subsequent math class, and there is a special thing we can do with it, but that is outside the realm of what we're looking at now. So we cannot break down a sum of squares anymore. We can't break down either of these any further either, especially this last one. It might look like it's a difference of squares, but because 3 isn't a perfect square, we can't break it down anymore. And so this is as far as we are able to go. So our final answer is x to the 4th plus 9 times x squared plus 3 times x squared minus 3. In the next video, I'm going to look at the two other special forms that we have.